Hello everyone, welcome to another session of 206. Hello. Okay, I think everything is fine. So this is my y-axis screen. Okay, this is my y-axis. This is my x-axis. I have just drawn my y and x-axis. Now, what is the first step? Well, the first step is that you have to find the moment of inertia. Hello, Hassan, how are you? Good to see you. So Ixx is equal to Iyy. Hang on for a second. Sorry. Ixx is equal to Iyy is equal to. So pi by 64. We did talk about this last time. 40 power 4 minus 30 power 4 is equal to 8.59 into 10 power 4 millimeter power 4. So again, you have joined us from the middle of the topic. I'm not sure whether you went over the book or not. But even if you understand this problem, I would be super happy. You can join us so I can explain to you bits and pieces, okay? So area is equal to, this is a buckling problem. Area is equal to pi by 4 into 40 power 2 minus 30 power 2. So I get, what is the first step? The first step is to find the radius of gyration, right? So what I am trying to do is I'm trying to find the radius of gyration. Now, Ixx is equal to this R is equal to Iyy is equal to ARy square, right? Now, Ixx is equal to Iyy. So there is no need to get worried right now. And R will come out to be square root of I by A. Now, quick question for everyone. What was the rule? If you have moment of inertia of x and y, they are not equal to each other. We select the one that is lower. We select the one that is lower. And subsequently, we also select the radius of gyration that is lower. So for example, if you have a steel ruler, I explained this in the last class. If you have a steel ruler, you're putting a load over it. It has to buckle. It will buckle on the weaker portion, right? We know that if I am putting a load, it will not buckle there because it is stiffer from there. So I have to go for the lower moment of inertia, subsequently lower radius of gyration. And in this problem is relatively easy because Ixx and Iyy are equal to each other. So there is no decision making. But anyways, now the next question is, what is the critical load? Before you do that, you have to make sure whether Euler's formula is applicable or not. So the next piece of the puzzle is you have to find the limiting value. Agreed? So the formula was sigma critical. What was the formula? Sigma critical is equal to pi square E divided by LE over R, right? Everyone agrees? Hi, Usman. Then in order to find the limiting value, what will you do? You will substitute the value of proportional limit or yield stress. So you will substitute 300 into 10 power 6 pascals is equal to pi square multiplied by 2 multiplied by 10 power 5 into 10 power 6 pascals divided by anyone? LE over R. So what is the value of LE over R? You will write LE over R. Effective length divided by R. And there is a square as well. So you get LE over R is equal to, so this is our limiting value, LIMMITING, limiting, LIMITING. This comes out to be equal to, can you use a calculator and let me know limiting value? Okay, in my notes, it says 81. Now, what is the next step? Now that you have got this limiting value, my next step is, what is the LE over R actual? Ghazal, this is where we stopped last time, right? We were doing this problem, if you remember. So now let's talk about LE over R actual. So actual LE over R is equal to question mark. How can I find it? Okay, so what is the LE? You have to look at the 4 cases. So you can flip your notes, and in those 4 cases, you have to figure out what is the case for pin. Sorry, hinge. Wait, pin, hinge, revolute, whatever. LE is 2.5. No, I'm.
What did you say?
Okay, yeah, LE equal to L.
Yeah, LE. What did you say about the results?
81.
Oh, okay.
Sorry, I think this projector.
Square root by writing the expression.
Oh, sorry. Yeah, so it is 81. You mean, actually the whiteboard is cut for some reason. I don't know why. I will drag it here. Yeah. So I took a square root. Okay. Now, on those 4 cases, LE is equal to L, right? This is what you said, Usman. LE equal to L. Okay, that's fine. So he looked at the cases, and the hinge case is LE equal to L. Now, if LE is equal to L, then LE over R actual, why don't you tell me? It becomes equal to 2.5 meter divided by, what is the R value? 12.5 into 10 power minus 3 meter. So LE over R actual comes out to be
0.2.
okay, it comes out to be 200. 200.
Yeah, 200.
Okay, now that you have done it, now you will arrive at the final thing. Are we allowed to use Euler's formula? Number 1. Number 2, would the structure actually buckle? These are the 2 questions that you have to answer. It will fail under buckle or it will buckle. Actually, if you open the Hibbeler book, so you have to go through some textbook reading. It has a nice buckling topic. So yeah, go over those pages as well. Anyways, it will buckle or it will fail under buckle. Both the sentences are correct. So you will say LE over R actual is greater than LE over R limiting. So it will buckle. It will buckle. And when I say it will buckle, I mean, I'm implying it will fail. No? If something buckles, it's a game over. It will buckle, it will fail under buckling. So it will buckle and I am allowed to use the Euler's formula. Now, if I am allowed to use the Euler's formula, can you please look at your notes and tell me what was the Euler's formula? It was P critical is equal to, and by the way, you have to tell me to move the screen to the right because I cannot see from my laptop that you cannot see. P critical is equal to pi square I over LE square. And you can do the number crunching yourself, but let me do it for you. Pi square is pi square. Elastic modulus is 2 into 10 power 5 into 10 power 6 pascals divided by, no, I think I've missed something. There is moment of inertia as well. What was the moment of inertia? I think the moment of inertia was, oh, okay. So I think what we can do is we can play it a little intelligently. instead of using this, although you can substitute the value of I will play it a little more intelligently. I will actually use the formula pi square pi square yeah, good. Pi square I is equal to I is equal to AR square. Correct? I think this is what you were telling me, right? I hope. So our students are correct. Thank you. LE. Our students said, why don't you do like this? Okay, now what you will do is, this will be actual, of course, come on. So now what was LE over R actual? It was, I'm not sure why my notes have something different, but anyways. So I will write the 200 square. So why don't you tell me the P critical? I hope I haven't made a mistake, because I think I have. Pi square. My notes are different. No, I have 27.3 here. This means I have made a mistake. Isn't it 27.3? Can you double check LE over R actual, by the way? This is wrong, LE over R actual. 29.3, okay. Yeah, 29.3. Hang on. Can you double check this LE over R actual value? LE is equal to 2.5 and the R value is 12.5 into 10 power minus 3. Can you double check? LE is 2.5 and R value is 12.5 into 10 power minus 3. 200. Okay. So P critical, what did you get, Usman?
49.3.
Oh, then my notes are incorrect.
So maybe the area is wrong because you multiply pi squared times 2 times the power.
Okay. No, everything is one. Okay, what is the I is equal to MR square? This is I is equal to AR square. Sorry. Yeah.
What do you have your answer as?
I have 27.13.
I have the
27.13. Thank you. Okay. Then it's mistake from some other students.
I use the equation, the original equation that we have written down in the first place.
Okay, that's fine.
P squared over LE squared EI.
Okay, that's fine.
But it shouldn't be different.
No, it's not different. Should give the same answer. Whatever. Probably some mistake. I don't know. But the answer is 27.3. So we have. This is not A. I is AR square. Yes, correct. So what is the value of area? I have to put area, by the way. Multiply by
500. 549.
Pi by 4 into, so multiply with the area, by the way. Now, Usman, now do it again. So I forgot to tell you, multiply with the area, and the area is pi by 4 into 40 square minus 30 square.
The idea is 549.7.
Have to convert it into meter, of course. So you will get the same answer. So this is LE over R actual. Okay. Or if you don't like it, you can use P critical is equal to, as Hussain used, pi square EI over LE square. You can use Hussain's technique or my technique. Either way, you will get the right answer. Again, this LE is the sorry, what?
The case is hinged in.
Actual. Yeah, actual. We have to talk about the actual. This is also actual. Okay. What is your name? Should we continue? Okay, on that note, let us talk about one more example. Okay. Let us talk about this example now. By the way, which R value did I select for the last problem? This both of them were equal, right? So it was not a problem. Okay, let's go over this. The question says we have this problem.
So then we found, we found R with an equation.
Sorry.
You know, I equals AR squared,
So,
that equation
huh?
for moment of inertia.
So
We use that equation to find R.
so
We solved this.
We saw the
Example.
we didn't just pick one of the radiuses of the, because there was both in and out of them. That's why.
I'm not understanding. Both of you are telling
So,
the same.
we
Different
solved this question.
We solved it. Okay, and your question is?
I'm telling what he said, like, we asked how we found R, right?
You mean we
Last-
have already done this problem?
No. You said last question how we found R, right?
Yeah.
You asked how we did it.
Yes. So we use I equal to AR square, and we in last problem RXX is equal to RYY.
Yeah.
So that's why we were not worried about selecting the lower R because both of them were equal. And his question is that we have already done this. Okay. I know that we have already done it. I actually want to add one more concept to it. So let me now continue. Oh, come on. So let me, he's actually right. We already did this. So there is a reason I am doing it again. I will explain to you what's the reason. So this is the problem. The question says, okay, let's do this problem. I will tell you why am I doing it again. So I am trying to answer Mirj's question. Mirj last time I remember said, what is the answer to this question? And I stopped in the middle of the problem and I started a new problem. So I have to answer his question. So let's do this question. Number one thing is that you have to find LE over R limit, right? So let's do it. LE over R limiting LIM equal to question mark. So you substitute the value of, for example, between proportional and yield. My suggestion is go for the proportional limit value. Substitute the value of sigma critical is equal to pi square E over LE over R square. And this time around, what I will do is I will say sigma critical is the proportional limit, 200 into 10 power 6 pascals is equal to, now I will say pi square multiplied by elastic modulus is 200 into 10 power 9 pascals divided by LE over R limit, right? LIMMITING. So give me the value of LE over R. LIMMITING. Give me the value quickly. Well, I already know the limiting value is 99. Now I will find LE over R actual. This is where we stopped Mirj, right? So LE over R actual. What exactly is this case? This is a fixed case, right? Do we have anyone who doesn't understand why it's not a fixed case or why it is? This is a fixed case. So you have to look at your notes. For the fixed case, what is the value of LE? 0.5 L. So 0.5 multiplied by 4 will give me 2, right? 0.5 multiplied by L, Usman told us. Okay, so it is equal to 2. So LE over R actual. Anyone? It comes out to be Okay, what is the value of R? The Ry is 30 millimeter, Rx, I don't know. So why don't you tell me, should I select Rx or Ry? Why? Because I have to compare between, this is very important, Ahmed, Iyy and Ixx. Look at the value of Iyy. It is given to me, and Ixx, I'm not sure whether it's given to me or not. Is it? I think in my question, I remember I gave it to you. So Iyy and Ixx are both given to me. Turns out that Ixx is, in fact, it is given to me. Sorry. This is Rx and this is Ry. You have to select the lower R value. In an exam setting, between the two moment of inertia, you have to select the lower moment of inertia. In a buckling problem, you have to select the lower R value, the radius of gyration as well. So I have to select the lower value. This is why everyone is telling me 30. They did not tell me 180. So I select the 30 value here divided by 1000. So what is the value? I get 66, 67 or 66, whatever. Okay, now tell me LE over R actual. So Mirj, now I am about to answer your question. LE over R actual is smaller than LE over R limiting. Will this structure buckle or not? No, it will not buckle. It will not buckle. Buckle word, when we actually use it synonymously with failing. If I'm saying it will not buckle, I mean it will not fail under buckling. So if it will not fail under buckling, then what we will do? This was Mid's question last time, because I stopped here and I moved to the next problem. So you will have to write we are and OT not allowed to use Euler's formula, because it will not fail under. We are not allowed to use Euler's formula because it may not fail under pure. So you will use the word pure here. Under pure sole buckling, or it will not solely buckle. So from here onwards, it's a new thing. I'm not sure how would you react to it. So I'm just writing a formula. I'm not gonna get into any derivations or stuff. So what we do is we are left with only two choices. Again, just bear with me. If you understand every single thing about buckling till now, I have a strong feeling that you will do fine in your final exam. From here onwards, you should also know, by the way. So now you have only two possibilities. It will fail under buckling plus yielding that is happening at the same time, or it will only yield. Again, if you haven't attended the last class, it's pretty much impossible to understand from here, because I did explain all of this. So now I will say, let's say it will fail under buckling plus yielding. So I will just write the formula again. I'm not going to get into derivations. This is
Isn't that the case when the actual ratio is actually close to the limiting ratio?
good. Good question. You know, these are all your comment is correct. But this is very much estimations. These are estimations. So what we will say is, we will say, although it's way less than that, you know what? I will try to have this assumption. You never know. Probably both of them are happening happening at the same time. So I will still use it, although I agree with you. So I will still use this with this thing in mind, that probably Hussain is correct. We will see at the end whether our answers are making sense or not. That was a nice comment by him, by the way. Pi square E. Again, this is the formula that you are looking at for the first time in your life. This is a Rankine-Gordon formula. Just let's write it down and just solve it. Don't worry too much about right now. 250 into 9, 2, 7, 2. I have to complete this because last time we had a couple of students who were saying that I left the problem in the middle. Pi square into 2 into 10 power 5 multiplied by 2000 divided by 30. I've converted everything into millimeter, I suppose. So the answer is 1483 kilonewton. Again, this is the Rankine-Gordon formula. At least if I put this in the formula sheet, at least you need to know, okay, oh, I will only use this formula if there is a combination of buckling and yielding is happening and my LE over R actual has come out to be less than the limiting value, and I'm not feeling good that I'm not allowed to use the Euler's formula anymore. Okay, just remember this bit. Now let's finish this, and I will probably talk about something else. I will just try to answer Hussein's question, because his question was, isn't only pure yielding happening? So I will just answer his question and we will call it a day as far as this topic is concerned. Yes, please.
So when there is no buckling, there will be a yielding. So for yielding.
For pure yielding, for pure yielding.
For pure yielding.
For pure yielding, I'm about to do right now. This Rankine-Gordon formula is when buckling and yielding both are happening. So we are actually in that zone where buckling and yielding are together. Structure is falling under both of them. Euler's formula is when the structure has fallen under pure buckling. Rankine-Gordon is when both of them are happening simultaneously, which is his comment that why are you even saying this when your LE over R actual is in the 60s and your limiting was in 90s. It's far, far away from 90. So how can you even use this formula? His question was very legit and very correct, by the way. Now I am trying to answer his question by saying, if you're not convinced with this assumption, let's say that pure yielding is happening. What is the formula? P over A, we all know, right? So what is P critical? It is equal to stress Y multiplied by A. What is the yield stress? 250 into 10 power 6 into what is the area? Anyone? I think area was 9272 into 10 power minus 6. What is the value of P critical? I have in my notes 2318 kilonewton. So now I will answer Hussein's question. What is the, and your MIT's question as well. So what is the critical load for this problem? Is it 1483 or is it 2318? 1483. I want to remain safe in my life. So if I have to say that I don't want to exceed the load, 1483 is fine. Although his question was very legit. Why are you even bothering to use this Rankine-Gordon when we are so far away? But my concern is the same. If I have to use one value between the two, you know what? I want to remain safe. I will still live with this assumption that probably both of them are happening together. And you know what? I don't want to exceed 1483. I don't want to take a risk. Now let me put pieces together. In the final exam, the most important thing in my eyes is you look at a problem. You have to be sure whether it's pin, the hinge, fixed, free, fixed, and whatever those four cases are. Number one. Number two, you need to know how to calculate the moment of inertia. After calculating the moment of inertia about both the axes, then you have to select the lower one, because if the structure has to fail or buckle for that matter, it will buckle along the weaker way. It will fail under the weaker way, right? So you will select the lower moment of inertia. Subsequently, you will select the lower radius of gyration value. Then if I have given you proportional limit, yield limit, whatever, you will use that to find LE over R limiting. Once you are done with it, then you will find LE over R actual. If LE over R actual is greater than LE over R limiting, you are fine. You will use the Euler's formula. If that doesn't happen, then you have to go through these two formulas. Midge, everything is fine now, right? So your question was, why did we just stop in the middle? I stopped intentionally because if I had told you last time, we would have gone away from our actual problem, which was buckling. The topic is done. I have given you a couple of examples as well. I also gave you, I think, one file. You also have the reading material. So everything is fine from my side. Any question?
Hocam, will you given this four cases in the exam paper?
Of course. Well, how can you memorize the 4 cases? Yes, I have to do.
Hocam, is the sigma critical and P critical giving the same answers?
P critical is force. Sigma critical is stress. Good comment. Let me go over that. Hey, his question is nice. He's saying that when are you using P critical and when are you using sigma? Both of them. Okay. Do you want me to repeat from here? Okay. Where did I use sigma critical? Here. When I was using this formula, pi square E over LE over R square, this one, Mitch, this one. Sigma critical is equal to pi square E over LE over R square. Instead of sigma critical, I used the yield or proportional, whatever, and I calculated the LE over R limiting value. Done? Then I used this formula one more time, but I wrote it in another way, if that's your question. I said sigma is equal to P over A. Look at here. I took the A to the right hand side. Look at here. So I wrote the same expression one more time in another way. But this time around, in order to calculate the critical load, I had to use LE over R actual. That's the only difference. It's the same formula, but I'm using it differently. 100% clear? Sure. Okay. Okay. Well, everyone, I have to proceed to something else.
Hocam,
Yes. Let me ask. We have, yes.
Also, hocam, while deciding the R value,
You have to use I is equal to AR square. Yeah. Okay.
we need to look at firstly the moment of inertia, right?
You have to calculate the moment of inertia first. Okay.
the smaller moment of inertia's R value.
The small moment of inertia will give you the subsequent R that you have to use. If I have given you both the R's in the exam, you will select the lower value. Because if the steel ruler, imagine the steel ruler, if when it buckles, where it is, it buckles like this, no? It doesn't buckle on along the stiff way. Every time I say this, I stop. I have to use the right English. Yes.
Okay. Yeah, just
Okay. Ebu, Hasung, Komsal, Denise, and Aisha, do you have any questions or should I start one problem which is for revision? Okay, we have answer from Denise. All good. Hasung said everything is clear. Okay, then everything is clear. Okay, I will go over one problem from revision because I have a couple of questions from one of the students who said that there is something confusing in the beam deflection. So should I solve one of the problems, I suppose? Do you want me to solve this or you already know this? Should I? Is everyone comfortable in such problems? I thought that I should go over this. Should I solve it?
Yes, yes.
100%? Okay. We have, okay. Let's solve this problem, everyone, then. Okay, I hope this is clear. Okay, so the problem says that we have to, what is the problem? Okay, let's do this problem together. What is the first step? The first step is, the question says, for the cantilever beam and loading shown, determine the equation of the elastic curve for portion AB of the beam find the deflection at B and the slope at B. Now just remember, in an exam setting, Ghazal, if I give this question, I will actually may ask you to find the equation of the elastic curve for the whole beam. This is a possibility. I may ask you to give me the equation of the elastic curve for the whole beam. Right now, for this problem, I will only do the portion AB. So let's start together. What is the first step? Well, the first step is that you have to use the free body diagram. So my free body diagram is something like this. Okay, so first thing first, I have this little free body diagram. Why don't I play a little smartly, make my life easy? Because if I have, I really want to do this quickly now. So I think the free body diagram, I can just open with paint. I really want to save some time. So I think the free body diagrams, I'm just copying it. You have to make it yourself. What happened? Okay. Okay. Okay, so these are the free body diagrams. We made these cuts. So let's start. Number one is summation of Fy equal to 0. Summation Fy, and this is my positive, is equal to 0. Then I have Ra is my reaction minus WL equal to 0. Right, Mitch? And Ra is equal to W multiplied by L. Then I have anti-clockwise moment is positive. I will do summation of moment about point A equal to 0. This is the first step in your statics as well, right? You try to find the reactions. So you will get minus MA minus, why don't you tell me what will happen? So you will have this fellow is W multiplied by L, and it will act at the center, and you will have a clockwise WL multiplied by L divided by 2. Do you agree? Then you will have plus WL square over 6 equal to 0. Do you agree? WL square by 6 appears from the one that is acting at the corner. Although you are doing the summation of moment about point A, you are still including WL square by 6. And why is that? Because when you are talking about the whole beam, then everything comes into the picture. Now that you have done this, what will your MA be? Your MA comes out to be minus 1 by 8 WL square. Please remember that I am intentionally doing this to make your life easy. If you do not understand, you have to stop me. This is a revision problem. Okay.
Hocam,
Huh.
actually, it is equal to minus 1 over 8 W times the square.
Am I sure?
I mean the constant. So it is really equal to minus 1 over 8.
MA?
No.
This one. Oh, this one. This one is WL square by 6. The moment at the C, someone is applying this moment.
I think it's not, it's 3.
Really?
It's 3 and this.
Really?
We are square divided by 2 minus 1 square.
Okay.
divided by-
Sorry. One of the students said it is minus 1 by 3. I apologize. Hassan was right, by the way. Good. Thank you. Minus 1 by 3. Now, the next step of the puzzle is that you just try to make a cut. So where would you make your cut? You can make your cut here, right? Here, right? Make a cut here, and when you are making that cut, then you will focus here, right? So let's make a cut and focus on the second diagram.
What about this? Is it lower than L divided by 4? Right.
I'm not understanding. What are you saying?
X is it X lower than L divided by 2, or
Greater than L divided by 2.
X is greater than equal to 0 and our X would be less than equal to L. For the portion AB of the beam, my X will start from 0. My X will go all the way up to L. Then for the second portion of the beam, that is BC, my X will start at L and X will end at A. I hope it is clear. So now what I will do is I will make a cut summation of moment about, let's say, some intermediate point is equal to 0. Okay, so this is anti-clockwise, so I will put plus M. Okay, and then anti-clockwise, so this W will act, Mitch, this W will act at the center, right? So WX, so plus WX multiply by X by 2. This will be an anti-clockwise moment about this right corner. And then we will have minus RA multiply by X. That's it. No, there is one more thing, minus capital MA, right? Do you remember you calculated that? How can you forget? Because this is a cantilever beam. We cannot forget. So which is equal to 0, and we will have capital M comes out to be equal to minus half WX square plus WLX minus 1/3 ML square, WL square. Can you double check, please? Agreed? Yes, no. Please double check. Okay. So technically, if you personally ask me in the exam, your 80% struggle is still here. After this, your only struggle is the integration, which I'm sure everyone is good at. Trust me, the problem for me is still here. If you actually ask me, not from the numbers perspective, from awarding the numbers, of course, you will be awarded points from here onwards if you write the boundary conditions and everything else correctly. But from a student's perspective, the difficult part is still here. Now, all you have to do is write capital M is equal to, look at your notes and tell me the formula. What? Sorry?
Why is it RAX?
This is RA multiplied by X. Multiplication sign, sometimes I use. Okay, so the moment is equal to EI. Huh? D square V by D square V or Y, whatever, divided by DX square. What is Y? Deflection. I think in our previous problems, I was using V for deflection. That's fine. Now, what will this be equal to? Minus half W X square. This is a Rivian problem, as you know. Minus half 1/3 WL square. Okay, do the integrations and tell me. The first integration will give you EI dy by dx, right, is equal to minus half, anyone, W x power 3 divided by 3 plus WL x square by 2 minus half 1/3. So it was graded homework 11, if I remember, the last one. I think many of the students who submitted the solution, it was a copy paste of solution manual. So technically the submitted solutions were all wrong, right? Because I had asked to go through these steps and everyone just copied pasted the direct solutions from the solution manual, which is not a nice thing. So minus 1/3
WL square X.
I don't know, sorry,
WL square X.
WL square X
Plus
plus C1. So I don't know, for some reason our 1/2 WLX square is correct, minus 1/3 WL. Okay, so again in the solution that I have, I think the author has made this mistake. He is writing minus 1/3 WLX. You can just double check if I have made a mistake or not. I don't know why. but he or she has written WLX. As long as you are convinced that we haven't made a mistake, let's continue. Now, what is EI multiplied by Y? Anyone? EI multiplied by Y, it will be minus 1 by 24, 1 by 24, right? W x power 4, then plus WL by 2, x power 3 divided by 3, then minus 1 by 3 multiplied by 2, WL square x square, right? Plus C1 x plus C2. Done. Mirch, everything is fine. Now the last piece of the puzzle is to calculate the constants. So what is the deflection at x equal to 0? 0, because it's a cantilever. Deflection, I'm sorry, dy by dx at x equal to 0 is? What happened? Sorry. Okay. Y at x equal to 0 is 0. Then dy by dx at x equal to 0 is? It's a cantilever, right? So the slope will be 0, right? It will go like this. The slope will be 0 on the left support A. So it will be equal to 0. Should I stop now? You can calculate C1, C2 yourself by these two equations. Everything is fine? I don't know, whatever. So you can calculate yourself. I think C1 also comes out to be 0, by the way. I don't know. So yes, please. C1 is 0, I think. And C2 also comes out to be? I think so. So Y comes out to be equal to minus 1 by 24 Wx power 4 plus WL x power 3 divided by 6 minus 1 by 6 WL square x square plus 0 plus 0. Divided by EI as well? Okay. Divided by EI divided by EI. In an exam, if you directly write C1 0 and C2 0, unfortunately, I will have to deduct all the points. You have to go through all the steps and prove to me that C1 and C2 are 0. Yes, please.
We set that x equals 0. When the x equals 0, the y value will be 0.
Because it's a cantilever support, you can see on the left hand side, there is no deflection.
And also we set that slope.
Of
will
course,
be
it's a
0.
cantilever. It goes like this.
Okay. And also, we find C1 and C2 0. How we find?
Find it yourself. You have this equation of y. Instead of x, substitute the values. Substitute x equal to 0 and put y equal to 0 and tell me what will be the C2 and C1.
Oh, okay.
You have to do it yourself. So now you can find the deflection at, give me the value of what will be y at x equal to L. You can find similarly dy by dx at x equal to L. Can you find? Yeah, you can find, right? Sure. So you will go back. No? Should I explain this? So for example, this is the equation of y. Instead of x, substitute x equal to L. You will be able to give me the deflection at point B, y at x equal to B. Similarly, if I ask you, give me the slope at B. What is the slope? It is dy by dx. So you come here, find for dy by dx. This is dy by dx. Take the EI to the right hand side. What is C1 by the way? 0, right? So substitute C1 equal to 0. Can you give me dy by dx at x equal to L? Yeah, you can give me. No? In the solution, it has given. So now I have gone over the full problem. Now in an exam, for example, I can ask you, give me the equation of elastic curve for the whole beam. So the question would not end here. It will continue.
Because we will have to make a second.
You have to make a second cut. So the second cut, I will also answer Usman's question. Usman, give me 1 second. You have to make a second cut. So your second cut will have a moment for this portion, capital M equal to, then you will again write d square y over dx square equal to capital M, and then you will keep on continuing. S and everything is fine, right? Great.
Can you move down this?
Yes. Hang on for a second. Now, what will be the two conditions for the second portion?
Now we will have deflection will equal at L, and deflection at the first cut and the second cut when X is equal to L.
Good.
They're gonna be equal.
So
Derivation, the slope of that.
nice. Good comment. So now what you will do is you will have two more constants. So what you will do is you will say y deflection that you have got from this equation. Let's call this as, let's say y1 if you want to. This y1 at x equal to L, and the second deflection equation y2, let's say at x equal to L. They are equal, and similarly dy by dx at x equal to L is equal to dy by dx at x equal to L.
Yeah, what about the end of the loop? What should we write in here?
What?
What about the end of the road?
Yeah.
We will write on B point L. What about the end of this road?
L plus A.
L plus A.
Yeah. So your second equation, please remember, I have just to clear, I have done this whole problem, something similar in the class, in our class notes. Right now, this is a revision. That's why I'm not going through all the steps. So your second cut will be for x equal to L to x equal to L plus A. Okay, and this way you will find two more constants. Done? Anything else?
It will be L plus A minus X. Our second cut will be something else. Verify.
1 minute, 1 minute. Say that one more time.
So you know how we said the first cut, the distance will be X, right? From the first cut.
So now my x will start from L, and my x will be all the way up to L plus A.
Yeah, so we'll write L plus A minus X. That's going to be the distance of the second cut, the length. Is that what we're trying to say?
I did not understand your question. I'm saying that your x will start.
From B to C point B.
My x will start from left, by the way. So my x.
So it will be L plus A minus X. That one.
Hocam, if you look at this Hussein says this distance is X.
So
And he says on BC, which means
You
the
know where the
second
second
cut. What about the distance? He says it's A, his distance is A, and he says L plus A minus X for the second cut.
no, I don't know how you are planning to solve the question. I'm saying I can show you one of the problems that I have done in the class. Probably, I'm not sure whether I can open the Google Drive from here. Anyways, I'm saying x will start from L and it will go all the way up to L plus A. X greater than L and less than L plus A, less than equal to L plus A. X greater than equal to,
Segment.
sorry?
The length of that segment, what will it be? It will not be X because we said the left hand side is X, right? So what's the segment?
I'm telling you, x will be starting from L, x will be greater than equal to L, and x will go all the way up to L plus A. You have to open, okay, hang on for a second. I will open from Google Drive. In fact, I will have this. Can anyone tell me, no, you are not getting my point. You have to see already the question that we have already solved in the class. So let's say, let me pause the recording now. Just tell me, can you find the reaction at A and B for this problem? Just using the statics principles. No, you cannot, because the problem is this is a statically indeterminate structure. If you don't believe me, you can just try to do it by hand. Let's write RA plus RB equal to, okay, write it down. Then do the summation of moment yourself. You can keep on writing equation after equation. You will not be able to find the moment at the support, the reaction at the support B, or the reaction at the support A. You cannot do anything by just using the statics principles. So in the exam, if such kind of a question shows up, I can ask two different questions. A, give me the reaction at the supports, or I can ask you, give me the equation of elastic deflection for this one. How would you do? The first step will be, I'm not doing this whole question. I'm just showing you it's a very little problem. Number one, you will do the same thing as you usually do, right? You can just do summation of moment about a particular, make a cut. So if you do it, what will you have? Minus RA multiplied by X, right? Plus the fact that you have a counterclockwise moment acting at the end. And this M appears because you have made a cut. So that's your first equation, right? So you will write M is equal to RAX minus M naught. Here comes the problem. Do you know the RA? Do you know the RA? You don't, right? Because usually what you do is you say RA plus RB equal to any force that is applied. You cannot do anything in this problem of that sort. So you don't know RA. In this problem, RA is actually your unknown. How can you find it? You just continue with the drill. What is the M? M is equal to EI d square y over dx square is equal to, take the first integration, do the second integration. So you will have y is equal to, look at here please, y is equal to this big thing, right? Now here comes the last piece of the puzzle. How many unknowns you have? 3. How we have 3 unknowns? One is C1, then C2. Any other unknowns? The reaction RA, because this is a statically indeterminate structure. You cannot find the reaction just by using the statics principles. So what is your way out? Just do it. First thing, at X equal to 0, what is my Y deflection? For sure it is 0, right? It's simply supported. So you can find the first constant. Then what is the deflection at X equal to L? For sure your deflection is 0, right? That's your second equation. What is your third equation? At X equal to 0, my deflection is 0. At X equal to L, my deflection is 0. What is the third equation? This is a cantilever, right? Exactly. At X equal to L, my dy by dx equal to 0. So 3 equations, 3 unknown, you will be able to do it. Now, if we have any student who actually says, why are we even bothering to solve it like this? Oh, come on, why can't I just use statics principles? Okay, do it. Do it yourself. Summation of moment about point B equal to 0. You will keep on writing equation after equation. The first equation will be, if you want to use statics, do the summation of moment about point B equal to 0. First equation, M naught, of course, which is given to you. It's a constant, M naught minus RA multiplied by L plus MB equal to 0. That's it, right? So now your RA is known and your MB is, RA is unknown and your MB is unknown. M naught is given to you, that's fine. But with one equation, you have 2 unknowns, RA and MB, you cannot proceed. So that's why you have to go through this drill. For me, the whole beam deflection and this topic, I have done the revision. If you still have any questions, feel free to come to the office. I think you had a couple of concerns, right? You still can come to office and do let me know. Okay. Well, thank you everyone for your patience. Bye-bye.